Okay, in this video I'm going to introduce you to Monte Carlo methods in R. Here on the R website at 8.1 we've got a little introduction to it. Please go ahead and read the material, but I'm going to go ahead and just copy this. And I'm going to go ahead and paste it over. Just want to show you something that sometimes when you copy and paste things from the web, they go a little wackadoodle. And so I've got to do a little bit of cleanup. Most notably, I've got to shift all this over because it has a bunch of tabs in it for some reason, and I can just do shift tab, that'll back tab it. And then this got messed up, and I've already fixed this up above, so I'm just going to delete these two lines and show you that what I did was I downloaded the Doug Fir 8-kilometer data set from the website, the GSP 47570 website, and I fixed up my file path so that I can go ahead and load that. And there's my data, and you can see it's a typical data set for Doug Fir in California with a bunch of predictors in it. And we can go ahead and do NA omit. And now what we're going to do is a couple of things. First, you'll see there's a while loop here. So while loops are a way for us to be able to loop over and over again inside of R. So this is really our Monte Carlo. Anything that's in braces, you want to go ahead and tab over because that shows that this code is inside of this loop. Okay, and I'll talk a little bit more about that in a second. So here you can see that we're setting up some vectors. You can think of these as arrays. If you're used to using arrays in programming, I always do. It's an array or a set that we can put a bunch of values into these different variables for our AICs, deviances, and degrees of freedom. Then what I do is I go ahead and set up a sequence. Again, it's like an array of gamma values. In fact, we can just go ahead and execute these. Okay, and you can see here we've got gamma values just going from 1 to 10. So this is where we're going to go sweeping through our different gamma values to see which one is the best. And then we can do is we set up our loop. We set up a variable to be the starting value that we want to have. So in this case 1, which will be pretty common. And then I'm going to loop while count is less than or equal to the length of my gammas array. So in this case I'm going to loop 10 times because count starts as 1 and then I go 2, 3, 4, 5, 6, 7, 8, 9, 10, and it should loop through each of those different values. Then in here I'm going to go ahead and get a gamma value from my sequence or array, and then I'm going to build a model. This should look familiar by now. Okay, and there's our gamma parameter that we're feeding into the model. And then I'm going to go ahead and get the AIC from the model. And then this is how you add something to a vector or an array in R, is we actually use concatenate, and we're concatenating this new AIC value into our existing array to get a new array. Same thing here with our deviances and our null deviances and our degrees of freedom, which I just do a sum to sum up the estimated degrees of freedom in the model. Then count equals count plus 1. So this is really important. If you don't put this in here, your loop will run forever. Don't worry, it happens. There's a little stop button that comes up and you can stop it when it does that. Okay, but really need to do that. Now here's one of the keys to debugging loops or functions or any other type of control in R is what I do is first I go through and I actually write all this code before I put in the loop. But if you have any problems once the loop is there, the cool thing about R is you don't have to run the while, right? I ran up to count, and then I'm going to jump inside the loop. So after the brace, okay, and then I'm going to run what's inside the braces and make sure it all works. And it all appears to work. Then I can go down here, I can run the rest of my code. So I've just run the code without having to run the loop. So it's a really good debugging technique, especially in R where it's a little bit harder than most languages to debug R code. And then we can go ahead and run the entire loop. I probably should have printed something out or something, but this is a fairly quick model. And then I can go ahead and compute these guys and go ahead and plot these values. Okay? So there is a little bit more information on using loops in R on our website. But all you really need is to take these 3 lines of code where you set up a loop variable and then say while, whatever your while condition is, while you want it to stay in the loop, and then there's an opening brace, the code that's in the loop, and then at the bottom you update the count and you do a closing brace. Okay, so those 5 lines of code is really our Monte Carlo. That's what puts the, puts in the repeated part, not the random part, okay, but the repeated part. Here we're not doing randomness, we're trying different gammas by doing a sequence, but next step we'll go ahead and turn that into some randomness and inject that into our model, okay? So this is just a really nice method to be able to figure out what gammas we can use. And if you look over here, we've got our charts that show gamma just increasing from 1 to 10. Might want to do a different distribution here because it tends to be more interesting to look at the lower values. And you can see our AICs. Our AICs are lowest when we have very low gammas, which makes sense because that's going to be the most complex model. And then as we increase the gamma, which is going to simplify the model, our AIC is going to go up. And we've got this nice sigmoidal curve, which means we might want to pick something in here, right? Because here we're simplifying the model. It's not really impacting AIC. We don't want to be over here because that's too high, right? But any of these models are going to give us about the same performance. And this one will be simpler because it's got a higher gamma value. So that's that trade-off that we're looking for, okay? Now also over here we have percent deviance. Percent deviance was calculated by dividing the deviance of the model by the null deviance, okay, or the deviance if we explained everything. What you can see is that our deviance is low when we have small gamma, which also means we have a large number of parameters. The EDFs are the number of parameters in the model. So again, here's where we have our more complex model, higher performance, explaining more, explaining more of the deviance, okay, and also being more complex. Okay, so again, you know, no reason to pick this first value, right? That's too low of a gamma. We can move over until these curves start to go up, and we're really not losing anything. Certainly not in going from 1 to 2. We haven't lost anything in our performance statistics. Okay, and it also hasn't reduced the complexity of our model here with the EDF. So we may want to go down into here where we're starting to reduce the complexity of our model, and we're not losing out too much on the AIC or the deviance. Okay, so that's really how we select gamma, or how you can robustly select a gamma value.